Hey everyone, how are you doing? My name is Meidan. I'm a second year computer science student in the College of Management in Rishon LeZion. Today I'm going to introduce to you my advanced software development project I've made with my partner Shahar. First of all, I want to say thank you to our lecturer, Dr. Eliyahu Chaleschi. Eli, thank you. It was a pleasure learning from you along the way. Alright, let's take a deep into the project. The project is divided into 5 milestones. The first one is focused on the server-side architecture design, based on solid and GRASP principles. During the second one, we've implemented a server and a cache manager using files and socket streaming. In the third milestone, we've implemented an algorithm from pseudocode to object-oriented programming code. Fourth milestone was about programming a custom language interpreter. The interpreter is able to run a script based on commands and use these commands to control our aircraft. Fifth and last one, we've combined all the milestones together and made a graphical user interface user application using MVVM architecture, which allows us controlling the aircraft and looking for the shortest path by our algorithm. Awesome, it's time to run the program. Okay, let's run the server, solver server, and the client server. And we need the flight gear simulator. And I'll press the fly button. Alright, this is our application. Let's connect to the simulator. First of all, I want to show you guys the interpreter work. The interpreter accepts to get a script. So let's load the script. When I press the run button, the interpreter will get the script, interpret it, and send the instructions to the simulator to fly the aircraft, which make the plane run and leave the ground. Now we'll just need to wait to the simulator. Awesome. Let's run the engine. Okay, cool. I'm pressing the run button. Awesome. As you can see, the aircraft's moving straight on the path and leave the ground. And awesome. Alright, now I'll load the map, which represents a topographic map of the simulator. The colors represent heights. The green color represents higher heights, and the red color represents lower heights. So it goes from red to green. We're interested on the shortest path based on low heights, from the plane position to any target position we want. As you can see, the plane is located right here, and I'll choose this target. Let's connect to the solver server, which give us the shortest path. As you can see, it goes all the way from the red cells. And let's choose this target. Awesome. Remember, the higher it goes, the greener it gets. Okay, Let's move to manual. Let's leave the cockpit viewpoint. Awesome. Now let's move to the manual. You can see how I can control the plane from my joystick easily, how it moves. As you can see, the plane on the map is moving due to the location of the plane on the simulator. Alright, that's it. Boom. Let's go deeper in our program. Alright, now we will discuss about the project architecture. Here you can see the segregation between the server that listening to a socket and the client handler that defines the communication protocol. That segregation helps us to get a single responsibility for each interface. To be able to solve different kinds of problems, we used object adapters. You can notice the one called solver searcher. To be able to solve different search problems with different algorithms, we used the bridge design pattern, which allows us to search with any kind of searcher on any kind of searchable object. Let's talk about the client side. We've implemented the client side based on MVVM architecture. The view has two main data members that use to define the view functionality. The joystick displayer, which defines the functionality of the joystick, and the colorful map displayer, which extended the canvas and is responsible on the map functionality. As you can see, the relationship between these three parts uses observer pattern and data binding. The view observes the view model, and the view model observes the model. The similar variables in the view and in the view model use data binding to be updated with values changes during all the program. The view model is responsible to adjust the input for the user, so the model will understand it and vice versa. Let me give you an example. This is our joystick. He got his X and Y values from the user when he moves it. These values are bound to the view model, elevator, and aileron values. When I move the joystick, shortly afterwards, it invokes the move elevator and aileron function implemented by the view model. The view model adjusts the values and invokes the similar function at the model, so it sends the new values to the simulator. That relationship helps us to control and move aircraft controls by the user joystick. Alright, that's it. I was Maidan and this is my partner Shahar, who I worked with on this project in a collaboration. Thank you very much for watching.